What if I told you that deep beneath the surface of reality, scientists are discovering forms of matter that should not exist according to the rules we once trusted? Matter that doesn't behave like solid, liquid, or gas, matter that doesn't even follow common sense. At CERN, physicists are now identifying exotic particles that challenge everything we thought we knew about how the universe is built. These particles don't just sit still, they exist in overlapping quantum states, bound together in ways nature was never supposed to allow. Welcome to the strange world of Tetraquarks, where reality becomes flexible, unstable, and unbelievably weird. Viral. Daily. Content where cutting-edge science meets curiosity, and where the deepest mysteries of the universe are explained in a way that actually makes sense. If you love mind-blowing discoveries, futuristic physics, and facts that make you say no way, hit subscribe and join the VibeVerse family. Today, we're diving inside the world's most powerful particle experiments to uncover how CERN is revealing new layers of matter itself, layers that exist far beyond the atoms we see around us. Fact 1. What is matter really made of? Everything you see, your phone, your body, the earth is made of atoms. Atoms are made of protons and neutrons. And protons and neutrons are made of even smaller particles called quarks. For decades, scientists believed quarks only combine into stable ways. 3 quarks form protons, and neutrons to quarks form mesons, but nature had more secrets hidden. Fact 2. CERN is finding exotic matter at CERN. Using the Large Hadron Collider, physicists smash particles together at near light speed. In the debris of these collisions, they've found exotic combinations of quarks that don't fit the traditional models. One of the strangest discoveries is the tetraquark, a particle made of 4 quarks bound together in a rare and unstable configuration. Fact 3. Tetraquarks shouldn't exist, but they do according to older theories. For quark structures shouldn't be stable enough to observe. They were expected to fall apart instantly. But CERN experiments have now repeatedly detected tetraquarks that survive long enough to be measured. This proves that quarks can interact in far more complex ways than previously believed. Fact 4. These particles reveal hidden quantum force. Quarks are held together by the strong nuclear force, one of the 4 fundamental forces of nature. Tetraquarks show that this force behaves differently at extreme scales. The way quarks bind inside these exotic particles suggests hidden patterns in quantum interactions, patterns that may explain why matter exists at all. Fact 5. Tetraquarks live in quantum superposition. Here's where things get truly strange. Tetraquarks don't always have a fixed internal structure. According to quantum mechanics, they can exist in superposition, meaning their internal arrangement exists in multiple possible states at the same time. The particle isn't switching back and forth, it exists as overlapping probabilities until it is measured. Fact 6. Not to places, but many possibilities. When people hear superposition, they imagine particles being into places at once. But what's really happening is even stranger. The tetraquark's wave function spreads across multiple, potential configurations simultaneously. Reality itself becomes uncertain at this scale, not because we lack knowledge, but because uncertainty is built into the universe. Fact 7. Why this matters for physics. Each new tetraquark discovery helps physicists map previously invisible layers of quantum matter. These particles test the limits of quantum chromodynamics, the theory that explains how quarks behave. If the theory breaks down, scientists may be forced to rewrite parts of the standard model, the framework that defines modern physics. Fact 8. Exotic matter may exist where we heterotrack are created in high-energy collisions, but scientists believe similar exotic matter may exist naturally in extreme environments such as neutron stars, the early universe, or near black holes. Understanding these particles could explain how matter behaves under the most extreme conditions imaginable. Fact 9. These discoveries could shape future technology. While tetraquarks themselves won't power your phone anytime soon, the physics behind them could influence future breakthroughs. Better understanding quantum forces may lead to advances in quantum computing, high-energy materials, nuclear physics, fundamental energy research. Every leap in physics begins with understanding what reality is made of. Reality at the smallest scale is probabilistic, flexible, and deeply counterintuitive. What we once thought were strict rules are actually guidelines, and nature constantly finds ways to bend them. Beneath the atoms that build our world lies a quantum universe filled with exotic matter, overlapping possibilities, and forces that don't behave the way we expect. Each new particle detected is not just a discovery, it's a message from the universe, telling us that reality is far deeper, stranger, and more beautiful than we ever imagined. If this blew your mind, hit like, drop a comment, and subscribe to VibeVerse for more smart, viral, daily content that turns the mysteries of physics into stories you'll never forget. The universe is still revealing its secrets, and we're here to explore them, one particle at a time.